This middle group I don't care about. This is called the transition elements. So elements 3 through 12 on your list, I'm not going to concern myself with that middle block. Not saying they're not important. They are important. What we're going to focus upon, our time and effort, is called main group elements, and that's 1, 2, and then this should be 13 through 18 on your chart, or it can be like 3 through 8, because I think they have some divisions on there. It says 3, and they have letters associated with them, right? Is that what you guys have?
Right. 3B,
3A
3VB
through 8A when you take a look at the Roman numeral, right? So that's kind of what we're looking at. We're looking at the 3 Roman numeral through the 8 Roman numeral. What we're going to do, we're going to go down through, do a couple of these, and we're just going to fill out this sheet based upon our first A through F on this sheet. So, I'm going to show you how to do what's called an electron dot notation here in a second. Electron dot notation was developed by Robert Lewis. Robert Lewis was as a young teen, younger than you guys. He lived in Lincoln, Nebraska. He went to UNL for about a year or two, and I think he was like 13 years old when he started going to UNL.
How long was this?
This is probably 1900s, early 1900s.
So like 1920s.
Yeah. So then, what he did was he transferred out of that and then went to a more prestigious school back east because he was really good in chemistry. So he went, I don't know if it was Princeton or Harvard or one of those schools back east, and he got his degree and he became a teacher, and he in fact run a lab at University of California, I think at Berkeley. And he came up with this system of how to model these atoms and their electrons. And it's a really simple model, okay? Really easy to kind of understand. So first thing I'm going to do is kind of show you a simple way to model these electrons, okay? So you don't have to write any of this down. First thing is we'll put this, and this will be the nucleus, and then we have this first level. A lot of times it's known as, kind of shown as an orbital. It's not that simple. Electrons do not stay in a set orbital. They are outside the nucleus, but it really depends upon, they can be within a certain region. They call it a cloud. Anymore we call it a cloud. We don't call it an orbit because it can be a little higher in that orbit, a little bit lower in that orbit, and sometimes it's hard to find where electrons are located because when you put energy into it to find it, what do you think happens to the electron? It gets energy from that energy you're putting into it to find it, and it jumps to another spot. So it's kind of like trying to catch something that's really quick. It's just too hard to do. Okay?
Like a rabbit.
So that's the first level. Then we can take a picture of an atom that has more electrons that has maybe 2 levels. You've seen drawings of atoms, right? I mean, this is just this is really simplistic. So then we can have levels in the first level or the second level. They call these energy levels. And then, you know, as we know, as you get more and more electrons, they kind of tend to spread out, and you get more and more levels that you have to worry about. Okay? So we have just 3 levels we're going to talk about. Now the first level only holds 2 electrons. Okay, that's all it can hold. So the first level can only hold 2. So, and then the second level, then we know how many the second level holds. 8. Now, depending upon who's teaching this and how far they want to go, a lot of times teachers, and I will do in the other class, we'll talk about the third level having 18, but we're going to keep it 8, and there's a reason for us to keep it 8 without getting into the differences, okay? So I've got 3 levels, 2, Then the second level will have 8. And the third level will max out at 8, is what we're going to say. Okay?
So times by 4, if there's 2.
What's that?
Times by 4 then?
What do you mean times by 4?
So it just automatically hits 8?
Yeah. Okay. Now, every one of these atoms will want to have a full level. So, for this one, it will be full when it has 2 electrons. For this one, how many will be full? For this one to be full, the outer level, how many does it have to have? 8. For this one to be full, how many does it have to have?
8.
8. So, it's either 2 or 8. Well, you can kind of see after a while, once you get a few more than 10 and up, then everything's going to have 8. It's called the octet rule. Later on, we can talk about the octet rule. Okay. So we're going to start out with helium.
Helium.
Right? Now helium, what we're going to do is we're going to do what's called the Lewis dot notation. And by doing this, we're representing a dot to represent the electron that is in any of these shells. But we'll never show the inner shell. We'll only show the outer shell. This is the outer shell, and we'll show the outer shell and how many dots associated with that. So how many dots can I have total around any symbol? What's the most that I can have around any symbol? 8. Right? Because I'm only going to show the outer one. I'm never going to show electrons associated with the inner one once we get past a certain number of electrons. So for helium, I'll show 1 dot, and that's called the electron dot notation for helium. It has 1 dot, I'm showing that dot, and then I know that that dot represents an electron, and it's in the outer shell. Any questions on that? Okay, I messed up. This is hydrogen. So it'd be hydrogen has 1. Okay? Now, helium, look at helium. What's its atomic number, helium?
2.
So here's helium. So how many electrons will it have?
2.
2, and they're both here. So helium, we'd show 2 dots. If you notice, the first row across has how many in it? 2. Second row has how many in it? 8. Third row, 8. Fourth row, we eliminate this section, and so when we count across, it has 8. Right? So as we go on, we count across the row. The most we can put in the outer portion is 8. So let's do 1 in the second row. Let's do oxygen. Now we're going to look at oxygen, and I'm going to show you oxygen here. So the first 2 electrons for oxygen go here. And how many remains? So oxygen has 8 electrons, right?
Yeah.
Total. 2's there. How many's out here? 6. So I'm going to go 1, 2, 3, 4, 5, 6. Okay? So what I'm going to do on this is I'm going to show those 8, or no, I'm sorry, 6, around oxygen, and it looks like that. It shows 6. Does that 6 kind of look like this shell here? 1, 2, 3, 4, 5, 6. Right? I count across. Oxygen's here. I'm going to count across. 1, 2, 3, 4, 5, 6. I can count across any row, and that tells me how many electrons are in the outer portion of it. Okay, we'll do one more. Let's take a look at sulfur. No, we won't do sulfur. How about we do phosphorus? So where's phosphorus? Phosphorus is right here. Is that right?
Yeah.
So what we'll do is we'll start. So it has 2 in the first level. It has how many in the second level? 8. And in the third level, we'll count across how many's in the third level. 5. So 1, 2, 3. You guys won't draw these models very much. So 1, 2, 3, 4, 5. So around here I'm going to put how many? 5. And that represents how many electrons are in the outer level. So I just keep going. I can go on all the way down the bottom if I wanted to. And the most we can have in that outer level is going to be 8. Okay, so what I want you to do is I need you to use that system to do A through F on this sheet. Okay? So what I need you to do is I need you to use this system to do A through F and show the number of dots by counting across the row. And just use my symbol. I already have it written there. Just go ahead and put the dots around that one. So do bromine through krypton, and then see if you're doing it right here. We'll look and see if you did it right.
Which ones are colored?
The gases that are colored are halogens.
Yeah, that.
Okay, so bromine gains, strontium loses, lead loses, arsenic gains, sulfur gains, krypton doesn't do anything. Now, let's take it a step more. You got to tell me the charge it's going to be if it gains or loses. So you got to tell me the charge of each one of those on the next one. So for each element, give the new charge that it will become when it gains or loses. Okay? Go ahead and do that on 3A through F. Tell me if it charged, what's its charge going to be? Positive, and then positive 1, positive 2, positive 3, negative 1, negative 2, negative 3, negative 4, however many that is going to be needed. So tell me what the charge is going to be. You guys should be able to predict all of these in the future. You should be able to predict the charges of all these groups. Because if you know how to draw out the dot notation, then you can predict if it's going to be negative or positive and what its charge is going to be.
Because it's based on how many it has.
Based upon how many it has and how many it needs to give up or gain to get 8.
Alrighty then.
Tomorrow we'll do a lab. The lab will be, you'll take a solution, and inside the solution you're going to oxidize something and you're going to reduce something by putting electricity into it. So the battery is going to pull electrons from the solution on one side, and it's going to give electrons to the other side. And what you're going to do is you're going to form 2 different substances on either side. Okay? And the process is called electrolysis. You're going to be giving electrons to a certain element on one side, and you're going to take electrons away from a certain element on the other side. And then you're going to go ahead and look, make observations, and then fill out that other sheet I gave you of what's going on. Okay, we'll do that tomorrow. Remember, we talked about processing. If we process an element that's a metal, we have to reduce it. And so we have to have something that's willing to be present to give it electrons. And so that substance will be oxidized to give the electrons to the metal. And so when you guys turned in your little PowerPoint, there's a processing part of that, and usually that's what happens. Something's giving it electrons so that it can become neutral. and can be the pure form. So aluminum has how many dots? 3. It will tend to lose. It will tend to have a charge of a plus 3. And it will be what? Oxidized. Selenium has 6. It will tend to gain how many?
2.
So it'll be a negative
2.
2, and it is reduced. So now you know how to predict gaining, lose, what charge is going to be if it's oxidized or reduced. Okay?
Riley, this was probably the best you did in this class.
Piece of cake.
Piece of cake today. Hopefully you remember.
No, a lot.